Israel. So if I need to drive, let's say, to Tel Aviv, I will probably navigate with Waze. I will open my phone, I will open Waze, I will set a destination, I will drive there. I will probably get there because it's Tel Aviv, everything is packed. I will not be able to park anywhere near where I need to be going. So I will continue driving for another probably 15 minutes or 20, and then park somewhere, probably relatively distant. I will exit the car, open Google Maps, set the destination back to where I was supposed to go, and walk by foot and navigating with Google Maps. And this is strange because I could do everything with Google, right? I could drive, I could walk, I could even take a plane. But here it's kind of a consensus that you drive with Waze and you walk with Google Maps. And we kind of do that a lot in many different contexts. We use different tools for similar purpose. And there's a saying, what got you here won't get you there. And this is true in general, but this is not exactly true for Terraform. And I think many of you use Terraform to set up your public cloud infrastructure, probably instances, storage, buckets, whatever. And then when you create Kubernetes, probably with Terraform, then you switch to something like Helm and start deploying workloads into the Kubernetes with Helm. Now, my point is that Terraform is a great tool for any API, and as long as it's API, there's a lot of value for Terraform. So, hi everyone, I'm Lev. I'm CTO at TeraSky. I've been doing Linux sysadmin for a very long time. I've been a part of HashiCorp Ambassador for the last 3 years. And I love building those weird mechanical keyboards, as you see here on the picture. So if you're into that, please talk to me after the session. TeraSky, we are leading system integrator. We've been chosen as HashiCorp Partner of the Year for 2022. We hold a lot of competitives, and we're also super focused on Kubernetes. Most of our engineers are CKA certified and CKS certified. So Terraform, it's not only for infrastructure, right? It's a great tool for cloud infrastructure, obviously, but it's a great tool for any API. Great example, this is HashiCorp User Group. You probably use Vault. I assume, or I hope, no one here is using UI to configure Vault or CLI, and most of you use Terraform, right? Because it's declarative, we can put it in Git, we can store it, we can rollback, we can do all kinds of stuff. I do see a lot of adoption for Datadog for using Terraform, right? People create graphs, dashboards, all kinds of notifications, and it becomes very, very adopted. You can manage Kafka with Terraform. You can create topics, you can create ACLs. You can manage Postgres with Terraform. You can create databases, users, permissions. Obviously, we're going to talk about Kubernetes today, so you can manage your workloads, deployments, config maps, whatever. I don't know how many of you know it, but you can actually order pizza with Terraform. There's actually a provider for Domino's Pizza, and someone was actually great enough to create a Sentinel policy for Domino's Pizza provider that prevents you from buying Domino's Pizza with pineapple, because it's a crime and you probably shouldn't do that, but there's a solution for it. So when you're looking at Terraform, you can kind of consider it like this. If you go and you manage it as a multi-cloud, this solves your horizontal problem. This will address your kind of standards in terms of Azure and GCP and AWS. And when you're talking about stack level, right, you're talking about infrastructure and then Kubernetes and then maybe software on top of this Kubernetes, this is kind of vertical. And Terraform can actually cover you in all of those, and it will be the same standards that you already know and the same practices that you already developed. So it can be very, very powerful. So let's do some stuff in terminal and see why Terraform actually makes sense in Kubernetes and what is the value of it. So I'm running this automation, but the environment is live. I'm just, trying to avoid typos. So first use case is context. Let's say that we want to deploy something in our Kubernetes, but we want to get additional context. For example, I want to get knowledge about my VPC. For example, what is this environment of this VPC in the label? And then I will add it to the resource of my pod, right? So without knowing it, I can actually do this. So here's an example. I have an example TF here, and this is how we can do it. I will have my data source for VPC, and I will search for VPC that called Zero Trust. And then I will create, as you can see here, Kubernetes service. And in the label of this Kubernetes service, I will say that the environment is actually a data AWS VPC tag environment. And this will actually take tags from here and add them here. And this is the provider for my Kubernetes. I'm just specifying the kubeconfig here. So let's try doing that and see how it works. Okay, so you can already see above that it happened, but let's see it actually inside of the service. So I'm doing kubectl get services Terraform example. This is my service, and you can see that the label of the environment is dev, right? So this is convenient and pretty straightforward. Nothing new here. Let me show you another example that will make even more sense. So what about taking data source from Kubernetes? Because I want to know stuff that I don't know before I actually try to deploy things. What kind of stuff? So maybe I don't know what namespaces exist, and I want only deploy it inside of non-prod or prod namespaces. Or maybe I want to copy labels or annotations from another pods or another resources and apply them to my resources. Stuff like configuration of service mesh, stuff like configuration of backups. Or another use case may be copying a secret from one namespace to all other namespaces, because we sometimes need a secret for a registry or certificates available in all the namespaces. So here's how we can do it. What I have here is this data source, and this data source is Kubernetes all namespaces, and this will find all the namespaces that we have in this specific Kubernetes. The second thing is data source for Kubernetes secret. So I'm actually taking this API gateway certificate, and then I'm creating a resource of additional secret, and I'm just doing for each, for all those namespaces. It's a loop. And in all of the namespaces, I will actually create a secret copy. And this data will be the data that we actually took from here. This will just create certificates in all the namespaces. So let's see that. So you can see here's our loop, right? In all the namespaces. And if we take a look, you can actually see we have this secret copy here and secret copy here. And if we check the content, so this is the original one, right? This is API gateway cert, and it has TCG here, and we have like a CRT and key. So if we check a copy, it will obviously be identical. It's TCG, and you see we have two files. So this is convenient, and we use it a lot. Okay, what about resource statuses? What if we want to deploy something and then check what we have in the status of this resource, and then we want to leverage it somewhere else? So for example, we want to create a pod and then take some data out of there and update it in parameter store, or maybe save it in CMDB, or maybe place it in config map in a separate namespace. We can also place it in a separate Kubernetes, right? There's no preventions to do that. So here's how we can do that. In this case, I will create Kubernetes service, but it will be of a type load balancer. And the selector will be TeraSky is hiring yes. And this will wait for load balancer to become true. So we will actually wait until the ELB is available. Once it's available, we will actually create a config map that calls CMDB and populate the data with the host name of this load balancer. In addition, I will also create AWS parameter store, CMDB, and I will put the value of this address there as well. So let's apply that configuration. Okay, so it was created. First of all, let's take a look at the service itself. So we have our service, and you can see that in the status, we have load balancer ingress, and this is our DNS for this load balancer. And if we take a look in the config map, you can see that we have a data, and this is our load balancer, right? In addition, I will open AWS, and as you can see, this is the value of our parameter store, and we also see it here, right? And there's a lot of useful things that we can do based on this data. We can create monitoring, we can configure our WAF, we can enable all kinds of runtime protections just based on this data automatically and dynamically. So basically, this is very, very useful. It will take a couple of seconds to delete it. Let's see if there are any questions so far. Okay. All right. So next use case, variable validations. I don't know how many of you here actually using Helm for this. You can do variable validation with Helm with JSON schema, but it's not very convenient or simple or easy. I think Terraform approach is way easier. And we have saying in Israel that says you should create your variables with love or not create them at all. So you can do all kinds of smart things there. You can apply logic to your variables. You can make sure that they're exactly as you want them to be. You can make sure that they're not empty. You can hide them if you think they're sensitive and you don't want to expose them inside of your logs. So this is an example of what it would look like. Here, I'm creating a variable and it's called owner label. And I'm saying, first of all, that it's sensitive. And I'm also saying that the validation condition for it, that it should contain either depth or ops or security. And if it's none of those, I will throw an error message and I will say owner should be one of those. And then I'm taking this variable and I'm applying it here inside of the label. So let's apply this configuration, and I will make intentionally a mistake. First time I will say Lev. So I will get this error and it will tell me it should be dev, ops, or security. So let's try dev this time. And you can see that it will create it, and it's actually shown here in owner as sensitive value, right? So it's not getting exposed, so I can control those kind of things. So let's delete it and continue. All right. So I showed you before that there's a data source for find all namespaces. And it's true that there's one of those, but it's not true for all of the resources. There's no find all services or find all config maps, unfortunately. And I was waiting for it for a long time, and I was hoping it to appear, but HashiCorp did actually something even nicer. They created a data source to pull any type of resource, and let me show you how they did it. So what we have is, this is the first example, right? I can do data source for Kubernetes resources, and I'm just saying, this is the API version, and find me all the services in the namespace of kube system. And this feature, it exists like, I don't know, 20 days or something like this. This is relatively new. So once I'm actually applying it, I will show you in Terraform console that I now have a data source that actually contains the service that I didn't know that existed there, and I didn't know what was its name, but now I can actually see it. This is a kube DNS service, and I have everything about it, all its config, all its statuses, all I need. Now, there's additional stuff that I can do here. And let me show you, first of all, that I'm creating a pod. And this pod will have a name of test, right? So I will create it. And the other thing that I want to show you is that I have a data source for Kubernetes resource that will actually read this pod. And there's a reason that I'm using it. And let me show you the reason for it. So I'm applying this. And now let's take a look, first of all, at the pod itself. This is the Terraform pod resource. If you take a look, you can actually see I have a metadata here and I have spec here, right? But what I don't have is a status. So I actually know many of the things that I've supplied and some of the things that are in the specs, but I don't know anything about the status of this resource from the output of the console. So for this, if I actually take data source for Kubernetes resource, I actually can see a lot of things that I couldn't see before because they're not part of the schema. So I see host IP and I see pod IP and I see the phase that it's running and I see a lot of stuff. So now, even if the initial Terraform resource didn't include the status, I can actually run a data source for it and get output for everything that I need. All right. So I know you've been suffering all my CLI, and I'm sorry for that. And let's do kind of a short focus break and return your intention. So if you work a lot in a CLI, you probably type a lot. My probably most common command is ls, and I probably usually mistype it as a cell. And I don't know if that happens to you, but if it happens to you in Ubuntu, Ubuntu usually suggests to you installing a cell. So at some point, I broke and I said, okay, I will install it. And I don't know if you ever checked it, but this is what a cell does. It's actually a steam locomotive. So every time you're making this mistake, you actually get this nice animation, which is very, very convenient. All right, so next feature, dependencies. And you probably know it if you're working with Helm. You want dependencies, but you really can't have them. And Terraform this is one of the biggest features that you have, right? You have the whole dependency graph, and you can get implicit dependencies or explicit dependencies. So first, let's take a look at implicit dependencies. Basically, in Terraform, if I create any resource and I reference that in another resource, Terraform knows the order. Here's the example. I'm creating this Kubernetes config map that's called first config map. And this data just says that it's a first and content is whatever. Then I'm creating another config map that I'm calling second config map. And in the data, I'm actually referencing the first config map. So Terraform will know that this should be created first config map, and then it will create the second config map. If I want to do it explicitly, I also can do that. So here's an example of explicit dependency. I have a Kubernetes secret here. It's called first secret, and it has no dependencies or references here. It's just explicit data. And then I have Kubernetes secret that is called second secret. And I also have only explicit data, no references. And I can say that this resource actually depends on Kubernetes secret, first secret, so on this one. So now if I actually apply it, you can see in the output that the order was correct. I first see the first config map and the first secret, and then they are created. And then I have the second secret and the second config map. So it's actually created in the order that I expect. Okay. Now, I showed you a couple of Terraform resources, right? I showed you a Kubernetes pod, I showed you a Kubernetes service, I showed you all kinds of things. But what about things that are not kind of native to Kubernetes? There's custom resources. What can we do then? So there's a Kubernetes manifest resource in Kubernetes, in Terraform Kubernetes provider, and we can create anything that we want there. both standard pods or deployments or stateful sets, or even custom resources that are not exist yet inside of the provider. So here's the example, right? I intentionally taking this route.yaml, and this is part of a gateway API. This is basically creates a route, place it in this gateway, and it will take all the traffic that goes into slash and just forward it into facade service. This is just gateway API, very similar to Ingress, a bit more flexible. To turn this thing into Kubernetes manifest, all I have to do is this. I will cut this file and just forward it into this command. And this is how Kubernetes manifest looks. It says resource Kubernetes manifest, then whatever name that I want, and the manifest itself, that as you can see, this is a decoded YAML that turned into JSON. Very, very simple. You can turn all of your already existing YAMLs with this tool within a couple of minutes. But there's additional value to that thing. So Kubernetes manifest not only can create any resources that we want, but it can also wait on custom fields. If you remember, I showed you that I can wait for a balancer to be created inside of the service. But here what I can do is I can wait for any field that actually exists, for example, in the status. I can wait until the pod is running. I can wait until number of replicas is whatever. I can do regex. This is very, very powerful and flexible tool. Terraform testing. Now, this one is my favorite because we all talk about Terraform as infrastructure as code, even though we probably refer to it more like infrastructure as config. Most of the companies don't do any testing at all. Some of the companies that do testing, they usually do end-to-end. So what I see that a lot of companies do, they just do Terraform apply, wait until it's created. If nothing failed, they do Terraform destroy, and they know that this is probably functional. In reality, in software, end-to-end testing are rare because it's very expensive and hard to build them. So in real software development, developers use unit testing, and they do integration testing, and they do contract testing, right? To know that I didn't break any API, all the logic is correct, and everything can actually work together. So Terraform actually comes with this built-in Terraform, built-in testing provider that you can use, and it's actually part of Terraform. It's experimental, it's still in the process, but you can already use it. This is how it works. So I have a main TF here, and I'm creating this service account. And if you notice, the only thing that I'm doing here, I'm specifying the name from this variable, and I'm specifying that auto-mount service account token is false. I will explain later why I'm doing this. There's a reason, and if you're already working with Kubernetes 1.24, you probably know, but this is what I'm doing. And then I'm just getting the input of a SA name, and I'm outputting the entire service account. So this is my Terraform. How do I test it? First of all, this is my directory structure. I will have a test here with a subfolder of defaults and my defaults TF. This will contain all my tests. This how tests working. I'm actually requiring a test provider, and this is a Terraform built-in provider. And then I'm actually calling my main mod and my main module. And if you see the source of it, it's actually 2 folders up, right? So it will be this main. It's this file that you saw before. And I'm providing the input to it, and I'm saying that it's Lev. And then this is my test resource. This is test assertion. What I'm doing here is I'm saying that I want to run 2 checks. First one will check if the name of the service account that was created is Lev, because this is what I provided here. The second check is checking if the token is false, right? Because this is the logic, this is what I want to test. So now I'm just running Terraform test. And if everything functions correctly, I should get an output, right? So I get success because everything happened exactly as I expected. What happened behind the scenes is that Terraform actually applied my module. It created the service account. It checked all those logics and then it destroyed it. So if I'm checking now with kubectl, you can see that I don't have any Lev service account here, right? So it's actually creating, testing, and destroying automatically. So let's get back to the slides and talk a bit more about Terraform. So we spoke about testing, and you probably should do it. And there are a couple of articles here and videos that I will share with you. So those two, it's by Ned and Anton Babenko, that explain in more details how you can do testing and what can be done there. And there's this great blog by Rosemary Wang that explain how you can do contract testing with a Sentinel. So this is very, very useful. If I'm comparing Terraform modules to Helm chart, I can actually compare like where I can store this. So there's actually a lot of convenient locations where I can store my modules, right? So I can store it in Git, I can store it in S3, I can store it in directory, I can store it in HTTP, I can place it in a registry or anything that simulates registry protocol. It can be Terraform, it can be other open source project. So there's actually a lot of convenient locations that probably available in most organizations. Another great thing in Terraform Kubernetes is how they work together. So Terraform provider for Kubernetes actually can work from the pod itself. And if you won't specify anything, it will automatically go and just leverage the JWT token of the pod itself to communicate with Kubernetes. So the only thing you have to do is just specify the proper RBAC for this pod, so he will be able to create or do whatever this Terraform is doing. The second thing that you can do with Terraform is actually store the state inside of the Kubernetes itself. So this is kind of convenient and make it all working nice inside of the Kubernetes itself. Now, as you can see, there's a lot of great things that you can do there. And we covered all of those. I hope you remember at least some of them, like context or the data source, dependencies, and the testing. But as any software, it's not perfect, right? There are still bugs. I've created this issue a while ago, about a year ago, of CSR, for example, that you want to create with Terraform, and it's still open. Probably a tricky, challenging API to solve, but basically Terraform will claim that it failed to create it, even though the certificate is created in Kubernetes. Service account, it's another issue. So for now, if you're working with Kubernetes 1.24, the default secret for service account is no longer created, but Terraform provider will actually wait for it to be created. So you cannot use it, and you have to do all kinds of workarounds that are available, but it's a bit not convenient. Data sources that I showed you before, they are very, very powerful, but they also have a couple of challenging if you have all kinds of unexpected fields like managed fields or another things. On the other hand, I see that the developers are very, very active. You have release almost every month, and the momentum is insane, right? It had just this week 2.5 million downloads. So there's a lot of people that actually using it, and this is very, very powerful and super adopted. So I think it has really great momentum. But there's another thing. When you considering using Terraform for your Kubernetes, you actually considering the entire ecosystem. It's not just Terraform, it's everything that HashiCorp brings. So it's Consul and Vault and another tooling. So for example, Consul Terraform Sync. So Consul Terraform Sync is another tool that we can use. So let me show you what it looks like. Basically, it will allow us to do event-driven infrastructure, meaning right now we work in a way when we want to create specific infrastructure. So we write it and then we apply it or maybe commit it into the Git, and then things happen because we initiated them. what we want to do is we want to kind of be event-driven. For example, someone deployed a new service into our environment, and based on that, we actually want to do some stuff. And this is what a console Terraform Sync actually allows us to do. So let me show you, first of all, my console. This is console UI, and console is a service discovery. So console actually shows me and discovers automatically all the services that are created in Kubernetes. So you can see that those are the services that exist in my Kubernetes. And if I click on one of them, there's actually a lot of knowledge that I can know. I can see here the address of the load balancer. I can see the port. I can see all kinds of tags. There's a lot of knowledge that I can pull out of it and provide it to my Terraform to do all kinds of automations. So I actually have a pod running in my environment that's called CTS. It's Console Terraform Sync. And if you take a look what I have inside of my, what processes I have my Console Terraform Sync that is actually running from this file. So let me show you what configuration for Console Terraform Console Sync look like. I'm saying that this is the console that contains all the services that I want to be triggered by. And this is the whole logic of this thing. What I'm saying is this: every time a condition in a service changes and look for the services that match this regular expression, in my case, is just any service, simply run this module. That's it. So this is event-driven automation. I can say anytime new service changes or deploy, run this automation. And in this module, I can have whatever I want. So this is the directory structure. I will have my module. I will have sync tasks that will be auto-generated by Console Terraform Sync for me to work. Inside of this directory, I will actually have a main file, a Terraform TF-vars that contains all the services with all the details and all the variables that I need. Main file is super simple, just my providers and this part that says run this module, take as a services these variable services. And you're probably asking where I take it from. You take it from terraform.tf-vars that is auto-populated for you. This is just the details of all the services that you saw in the console a second ago, with everything that you need: address, port, metadata, tags, anything. So you can just take it as input and run any automation that you want. In my case, this is the automation. It's just a boundary configuration, main, output, and variables. What I'm doing in this case, I'm taking any new service that has been deployed and configuring kind of VPN for the developers to be able to connect to it automatically without any intervention in the middle. All right, you suffered additional CLI, so let me give you another break. Another common mistake that I usually do when I'm trying to type Git, I'm typing this, GTI. And there's another great tool for people like me that don't know how to type. It gives you this Golf GTI animation and also a manual for Git. So let's go back to the slides. So as I mentioned, Console Terraform Sync can do all kind of event-driven automation, and shameless plug, I did a talk on it, I think about a year ago, and I would be really happy if you could watch it, because for us, we found really a lot of useful cases for it. All right. You also get Vault as part of this ecosystem. So you can do a lot of smart things. You can pull data from Vault, and it can be all kind of sensitive stuff. You can now use Kubernetes secret engine. So Vault can actually generate service account, and you can use it in your provider to actually communicate with the Kubernetes. You can also run Vault agent as a sidecar and issue a token for your Terraform that you can leverage for authentication. All of this basically means that you can have no zero password, right, problem. So basically that means you can pull all the sensitive data in the world and you don't need to specify any sensitive data in the config. Do you like writing YAML because you're working with Kubernetes, it's okay. I'm personally not judging you. I'm just putting this here. This is Mitchell Hashimoto, and he personally thinks that YAML is never an answer. But if you still love YAML, then there's a solution for you as well. There's a Terraform Cloud operator that allow you to write this type of YAML where you can create a kind of workspace and you can specify the module that you want to provide with the version that you want to provide with the outputs and variables and do kubectl apply on it, and it will work just any other YAML. And if we already mentioned Terraform Cloud operators, there's a Terraform Cloud. And this is also part of the ecosystem. And most of what I'm talking about is free. And most of it, so there's a disclaimer. So you get GitOps out of the box. Basically, Terraform Cloud connect to your Git. Every time you commit something into your Git and push it, Terraform Cloud can apply it. You get notifications for free. Slack, mail, webhook, whatever you want is integrated so you can have it as part of it. You can have choreographed execution. You can have multiple workspaces that are triggered one after the other. So for example, you can create your VPC, then you can create your EKS, then you can deploy there some stuff, and then you can go and configure your monitoring. And you have policy, and this is where it's not free. This is a paid version, but policy allow you all kind of smart stuff. You can write it with Sentinel and now also with a Open Policy Agent. And you can do stuff like checking if everyone provided labels or CPU and memory, but you can also kind of prevent people from deploying during the weekend because you like your production and you like your weekends as well. So there's a lot of value in integrating your Terraform with Terraform Cloud as well. So what I hope the future for a Terraform provider for Kubernetes brings us. So first of all, I was hoping for better data sources, and actually I think I've got them. I think this issue that I've opened was really elegantly resolved by this new data source. I still hope for better status handling. I think that what we have right now can be improved. Instead of doing additional data source for the same resource that I just created, I would really like to have a status of each resource. And I would really like to have those weights that I have in Kubernetes manifest for any resource, because this will be really, really convenient. So with that, I want to kind of summarize, and there are a couple of things that I want you to take from this session. One is, I know I triggered a bunch of people when I said that Terraform is better than Helm. I didn't mean it. Helm is here to stay. Helm is great. Helm has huge ecosystem. It's not going anywhere. This is obvious. But Terraform is widely considered to be an infrastructure creation tool, and it's a great tool for any API. And this is how I hope you will see it after this session. And if you want to work with Helm, Terraform actually supports Helm provider, so you can use that as well. And basically, what I'm suggesting is this. If you're using any kind of software that you got from outside, Mongo, Kafka, MySQL, you probably should keep using Helm. It makes no sense to try and turn it into Terraform. But if you are creating software for yourself and you're not shipping it to your customers, and you're deploying this to your environment, maybe based on what you saw today, it will make more sense to actually do it with Terraform, because all of the things that I've mentioned and probably all the practices and experience that you already have. So that's my session. Thank you so much. And if you have any questions, I'll be happy to try and answer them.
Yes, thank you, Lev, for this presentation. Let me share you the question we got from the audience. So I will stop. Where is the question here?
Right. So you can also create in the same manner that I showed you with Manifest. You can create CRDs, and this can be one of the things that you can do.
Sorry. Sorry, it's okay.
Yeah. And the second question, so with Terraform, we not only deploy infrastructure, but also can automate the process. Yes, this is my idea, right? And I'm saying that you can actually deploy your software and do all kind of things with Terraform. I know the questions. Yeah. Okay.
So thank you for your presentation. It was very insightful how to use the Terraform with Kubernetes. And for your information, for the next event, we have many events from HashiCorp, Hashi Days in June 13. And here all the list of all the events. I will share with you all the link after the presentation, after the sessions. So feel free to register. And for HashiCorp user group, the next event will be on May. And if you have any ideas for the subjects, feel free to share with me any topics you would like to see during these events. Thank you very much for attending. And thank you again for Lev. It was very, very nice. And you will have the register session in HashiCorp User Group YouTube channels. And visit it if you want to see back again the presentation. Thank you very much and enjoy your evening. Bye-bye.
Thanks a lot. Bye-bye.
Est-ce que